Alright, part 7, we're identifying the cation and the ion from the given compound. So you need to write the cation, write the anion, and then also write their charge. So this one, there's actually a periodic table trick to this. You can write this down on your periodic table, but group 1 is always going to be +1. Group 2, +2. Group 3, +3. 4 is going to be a little tricky. Remember, carbon is a nonmetal, so that's going to be an anion. And then transition metals down here are going to be cations. So that one's a little tricky in this column. But then when we go to group 15, these are always going to be a -3, -2, -1 charge. And so if you write this onto your periodic table, this can save you a few steps in the process of trying to figure out the charge and looking at the valence electrons. And this is going to help you a lot for this one. So we're starting with cesium and chlorine. So our cation is cesium, anion is chlorine. If we look at our charges, cesium is right here, group 1. So that is a +1 charge. Chlorine is in group 17. Chlorine has a -1 charge. Now 48, we have calcium and fluorine. So let's check our table. Calcium, group 2, has +2 charge. Fluorine is in group 17, -1 charge. So if we check this out, this works. So if calcium is a +2 and fluorine is a -1, then -1 times 2 fluorine in this compound makes -2. So that's just a way you can kind of backtrack, double check, make sure your equation is right. So 49, we have Na, and then the polyatomic ion OH. So we can look on the board for Na, and A has +1. And then we can check our polyatomic ion sheet for OH. Hydroxide right here is in the -1 box. We can also see, other way around, that this does check out. Na, so this is +1, -1, perfect. So calcium, and we have OH here again. OH is still going to be -1. Calcium, we did up here, we said was 2+. If we backtrack, 2+. OH is a -1, so we have 2 of them. So 2 times -1, -2 charge, those will cancel out, so that is good. Now we have potassium and NO3, so let's double check here. Potassium, +1. And NO3 is right here, -1. +1, -1, checks out. So here we have iron. This is a transition metal, so we're going to have to do a little extra work. We know iron will go here, and NO3 will go here. And we just saw NO3 has a -1 charge. I wrote those backwards. So in order to figure out the transition metal charge, we need to solve backwards. So if NO3 has a -1 charge, 2 times -1 means overall we have a -2 charge. And so we only have one iron, so that would make iron positively charged by 2 to match up with this equation. So now we have iron, oh my goodness, I struggle at my F, and oxygen. So if we look at oxygen over here, -2. Now we need to solve for iron. So if we have a -2 and 3 oxygens, our total charge on our oxygen side is going to be a -6. So we need to match this on our iron side. So if we have 2 irons, we need to figure out 2 times what equals 6. That would be 3. So we would have a charge, here, make that more clear. So we would need a charge of 3 to get 6 plus. So you see how I did that? I found the charge of oxygen because we know that one for sure, it's always going to be the same. And then we solved figuring out 2 times what equals 6. So 2 times 3 equals 6, so we have to have an iron charge of 3. We're going to do something similar here. So if we look at aluminum, has a +3 charge. Oop. And SO4, if we look here, SO4 has -2. So let's just double check, make sure this is right. So if we had a -2 charge here, that means our SO4 overall is going to be -6. Aluminum would need to be +3 charge. 2 times +3, +6, cancel out, perfect. Now we have calcium and CO3. Calcium +2 and then CO3. There it is, it's in the -2 box. And those work out perfectly. Now we have iron and oxygen. So first we need to solve oxygen. Oxygen is a -2. There we go. So to match this up, we only have one oxygen, so this overall charge here is -2. So our iron then would need to be +2.